So my team, we may not be doing questions in the order you learned it in class, like to say, oh, first we're doing questions on subject of the formula. Oh, now we're doing whatever. We're just doing a full paper. So the order we do is governed by the paper. So we are not going to do the topics in that order. But what I'm ensuring in solving these papers is a question from a certain topic. When you see us do it right now, you should have the principles in place for you to do any other question you get from the same topic. You understand? So it's going to be whatever comes because we are governed by what the question had, the paper had. Okay? But whatever we are doing in this paper, it is illegal for you to meet it again in another paper and fail to do it, because what we are learning is going to be the principles of that question. So now we know that we have 9 topics. If you're not sure, go watch the video where I talked about it. It's at the top, okay, of the playlist. Okay, check the playlist link in the description if you don't have it. Right, now, what am I saying now? Here's the thing. Of the 9 topics, the question which we have right now, what is the question? Let's read the question, okay? Tatiana, please read the question. This time, Tatiana will say, calculate the lower bound of the density of the metal. I'll say, I'm proud of you. Exactly. The question is asking for the lower bound of the density. Don't read the other stuff. We will use them, but fine-tuning it to the question we have been asked already. So the question wants the lower bound of the density. Question wants lower bound of density. So how do you do this bounds? Bounds is in topic code number. Topic 1 out of 9. How do we do bounds? When you're doing bounds, when you're getting any bound, any type of bound, you have to, we'll see the concept. And we'll see how it goes when we're calculating. Let's get to density. What is the formula for density? The formula for density is equal to mass over volume. So, now, you can never, class, if they say find density, find bound of density, the lower bound of density, you can never, ever directly find the lower bound of something calculated. What we can find bounds of is for things that are measured. So here's the thing. What did we measure? What are the things that we have and what were they measured correct to? Because when you're solving bounds, you always look at what it was measured correct to. So we had volume. It was measured to the nearest this. We had mass. It was measured to the nearest this. So for these two, I can find their bounds easy. So I can find the bound of mass, the lower and the upper, because I have to the nearest. I know what they were measured to the nearest. Then volume I can, because I know what it was measured to the nearest. Now the thing of it is, when I have these, I can now combine them in a special way to get the bound I want for density. So now, what do you want? You want lower bound for density. You want the smallest value for density you can get. Now, how do you get lower bound for density? Remember, you can get the bounds for mass. You can get the bounds for volume. Now, you want the lower bound for density, which means we want density to be as small as it can get. What you're going to do is you are going to get the upper bound of the denominator and the lower bound of the numerator, and you are going to have the lowest value of the density thing. So because we are dividing, how do you make something small when you are divide? Make the denominator big and make the numerator small. So I know in the numerator I can get upper bound and lower bound, but for me, I'm going to use the lower bound, because I want lower bound of density. I want to get my answer as lower bound. So I have to make mass small and I have to make volume large. Then that way I can find lower bound. So in other words, we are going to get lower bound of mass. Can we get it? Easy, yes we can, because we know what it was measured to the nearest. Can we get upper bound of volume? Oh, yes, we do, because we know what it was measured to the nearest. So now let's get those. So let's say we start with the mass. So now what you're going to do is, when you're getting the bounds, you go to what it was measured to the nearest and you divide that thing by 2. So this thing was measured to the nearest 20 centimeters. So what I'm just going to do, I'm going to say 20 centimeters divided by 2. I'm going to get 10 centimeters. Now, to get what do I want for volume? I want upper bound. To get the upper bound for volume, I'm now going to get the volume they measured and I will add 10 because I want the upper bound. If I wanted the lower bound, I would subtract 10. So first you go to what it was measured to the nearest. Divide that thing by 2. Then the value you get is the value you now use to get the bounds. So for upper bound, you add. For lower bound, you subtract. That value which you get when you divide to the nearest by 2. So it was to the nearest 20, we divided by 2, we get 10. Now to get upper bound, I will add 10 to the volume. So upper bound of volume, so let me say volume upper bound, sorry for this. I'm going to say volume upper bound is going to be equal to, what's the volume? 1240 cubic centimeters plus 10 cubic centimeters. And I'm going to get it as 1250 cubic centimeters. This is the upper bound for volume. Now let's go to get the upper bound for mass. Now what am I going to do? I'll say, what is mass measured to the nearest? Measured to the nearest 100. What do I do to that guy? I divide him by 2. And I'm going to get 50 grams. Now what do I want? I want the lower bound for mass. Now what am I going to do? I subtract this answer from the measured mass. Now what's the measured mass? 7,800. So I'm going to say the mass lower bound. This is going to be equal to, what's the measured mass? 7,800 minus this value, which is 50. Okay, this grams minus 50 grams. You get what? 7,750 grams. This is the lower bound. Now I'm going to now say density lower bound. This is going to be equal to mass lower bound divided by volume upper bound. So what is it going to be now? What is my mass lower bound? It is 7,750 grams divided by my volume, which is 1250 cubic centimeters. All right, so I'm going to make these things fit. I need to adjust some things to make it fit. Then now I can just get my final solution and I will be done. Okay? How easy is this? This is a walk in the park. A baby can do this. So now what am I going to get? Let's put it. Punch in the calculator now. Make the fraction with the special calculator which I told you to get. 7,750 divided by 1250. I will get 6.2. So my lower bound for density is 6.2. Then it's grams per cubic centimeter. So let's put that. So it's going to be 6.2. And the units are already there. So I am done. And this is my final solution and I can stop. So what have you seen? How to get the bounds. And that is for things that are measured. It's so easy. And you have seen how to get the bounds for things that are calculated, especially when it's a fraction. Okay, this is how you do it and you are done. Now we do the next question in the next video. Bye.